Hello and welcome to Cognito Key, where we get to unravel the science behind some of life's everyday wonders. So today, we're going to talk about something you've probably seen, maybe even have in your own kitchen, that super sleek modern induction cooktop. And we're asking a question that sounds like a magic trick, really. How on earth can it get a pan of water boiling like crazy, but the glass top itself, well, it stays cool enough to touch? What's going on there? Okay, so spoiler alert, it's not magic, but it is some seriously cool physics. We're talking about a way to heat things without any contact at all, which kind of turns our whole idea of making things hot on its head. All right, you ready? Let's get into it. So to really wrap our heads around induction, let's first look at the old school ways of cooking. You've got a gas flame or one of those glowing red electric coils. They work by getting super, super hot, and then they heat up the pan. But a ton of that heat just escapes and warms up your whole kitchen, right? Well, induction heating just throws that whole idea out the window. It's a completely different game. And yeah, that right there is the big secret. Induction doesn't heat the pan. It makes the pan heat itself, directly, from the inside, with absolutely no contact, no flame, no glowing hot surface. Nothing. So how in the world does it create this invisible fire? Well, it's all thanks to this amazing team-up of two basic laws of physics. Okay, so piece number one of our puzzle is something called Faraday's law of electromagnetic induction. Now, that sounds complicated, but here's the gist. If you have a changing magnetic field, it can actually create, or induce, an electric current in a piece of metal nearby, like your pan. And the crazy part? No wires need to touch. It's like an invisible force just making electricity appear. And our second piece is the Joule Effect. This one's pretty simple, actually. You know how when you rub your hands together, they get warm from friction? Well, the Joule effect is kind of like electrical friction. Whenever electricity flows through anything, it faces a bit of resistance, and that struggle, that friction, generates heat. So we have an invisible force making electricity, and that electricity making heat. Now, let's connect the dots. The best way to get this is to think about something you use literally every single day. A transformer. Yep, that little block that charges your phone, that's a transformer, and it holds the key to understanding induction. So a simple transformer has two coils of wire that aren't touching. You send an alternating current, that's AC, through the first coil, what we call the primary coil. What happens? It creates this pulsing, changing magnetic field all around it. And that magnetic field, in turn, induces a whole new electric current in the second coil, even though there's a gap between them. It's pretty cool, right? Okay, now here's the genius part. Your induction stove is basically just a transformer that's been split open. That copper coil sitting under the glass cooktop, that's the primary coil, what we call the work coil. And the second coil? Well, that's your pan. Your pan itself becomes the other half of the transformer. How clever is that? So that powerful magnetic field from the stove creates these little whirlpools of electricity right inside the metal of your pan. They're called eddy currents. And as these currents swirl around and around, they're fighting against the pan's own natural resistance. And what happens when electricity fights resistance? Remember the Joule effect? You get heat, lots of it. The pan is literally heating itself from the inside out. And this is the key takeaway right here. The cooktop itself isn't getting hot. It's just a magnetic field generator. It's the pan that gets hot, and that's exactly why the glass stays cool. The magnetic field passes right through it because glass isn't magnetic. This is also that aha moment when you realize why only certain pots and pans work. If your pan isn't magnetic, like aluminum or copper, the field just ignores it. You need something like cast iron or magnetic stainless steel to complete that transformer circuit. But why is it so ridiculously fast? I mean, it's almost instant. Well, there's another bit of physics at play, a secret weapon called the skin effect. See, at the high frequencies these cooktops use, those eddy currents don't just flow through the whole pan. No, they get crowded right up on the surface, on the skin of the metal. If you look at this chart, you can see the electricity is packed super tight right at the surface and then fades away really fast as you go deeper. This basically focuses all that heating energy exactly where you want it, at the bottom of your pan, for that immediate sizzle. What's amazing about all this is the incredible level of control it gives you. Engineers can be like DJs with heat just by tweaking a few things. They can change the frequency of the current. A higher frequency means more heat, faster. But it also depends on your pan. How magnetic is it? That's its permeability. And how much does it resist electricity? That's its resistivity. A pan that's really magnetic and has high resistance is going to get hot like you wouldn't believe. It's this perfect combination of factors that allows for such precise temperature control.
Okay, so we've got the kitchen covered. But believe me, this technology is so much bigger than just boiling water faster. The very same idea, clean, super precise, contactless heat, is an absolute powerhouse in the industrial world. So let's step out of the kitchen and see how this invisible fire is literally building the world around us.
Take metal forging, for example. We're talking about giant induction coils that can take a massive chunk of steel, a billet, and heat it to over 1200 degrees Celsius in just a few seconds. It's mind-blowing. And because the heat is born right inside the steel, it's way cleaner and more efficient than a dirty old furnace. It's just pure, hot metal, ready to be shaped into things like car parts. And it's a total game changer for welding and brazing, too. Remember that skin effect we talked about? Because the heat is so targeted, so localized, you can join two pieces of metal with an unbelievably strong bond without weakening all the metal around it. It really is like performing surgery with heat. It's that precise. But where the contactless part becomes absolutely crucial is in medicine. Think about it. Since nothing hot actually touches the object, you can do amazing things. You can create super pure materials for medical implants, or, get this, you can sterilize surgical tools while they're still inside their sealed packages. It ensures perfect, absolute sterility, which can literally be a matter of life and death. So, yeah, the next time you walk past an induction stove, you'll know exactly what's going on behind that cool-to-the-touch glass. It's not magic. It's just a really, really clever application of some basic physics, creating heat that is efficient, incredibly precise, and super powerful. It's changing our kitchens and our industries. And it really does make you wonder, doesn't it? What else out there could we heat up with these invisible forces? Thank you so much for joining us here on Cognito Key. If you had as much fun learning about this as we did explaining it, please hit that like button, share it with a friend, and definitely subscribe so you don't miss our next deep dive into the amazing world all around us.